Okay, my name is Mike Toscano, and we're going to graph rational functions. We're going to start with the problem x plus 4 over x squared minus 5. And the first step to graphing it would be to find the y-intercept, which you would plug in 0 to all the x's. So you're going to have 0 plus 4 over 0 squared minus 5. And that's going to end up being negative 4 over 5, the y-intercept. The x-intercept is the next step. In order to find that, you set the numerator of the equation equal to 0. So x plus 4 equals 0, and that's going to end up being x equals negative 4. The third step, you need to find the horizontal asymptote. And in order to do that, you have to find the limit of x to infinity, and you have to take the two exponents of the highest value, so that would be x over x squared, and that would be 1 over x, which in terms equals 0. The fourth step, you need to find the end behavior of the graph, and in order to do that, you have to find the limit of x is x to the plus or minus of infinity, and that would equal 0 from the previous part of the problem. The next step would to be find the vertical asymptote, and in order to do that, you have to take the denominator and set it equal to 0. So we're going to have x squared is going to equal to 5, so x equals plus or minus radical 5. The sixth step is to find the intermediate behavior. Intermediate behavior. In order to do that, you have to do, we'll do it down here, the limit of x to positive radical 5 to the right, to the right of the asymptote, and that is going to be equal to, it's going to have a positive on the top when you plug radical 5 into the problem for x, so the original problem. The top is going to turn out to be positive, as is the bottom, so that's going to be a positive infinity, which means the right side of the graph will be going upward. The limit of x to positive radical 5 to the left of the asymptote is going to turn out to be a positive on the top when you plug it in to the original equation, and a negative on the bottom. What? And that's going to turn out to be a negative infinity, so it's going to go to the it's going to go downward to the left of the graph. Now you have to find the limit of x to negative radical 5 to the right, which is going to turn out to be negative on the top and positive on the bottom. So that's going to equal to negative infinity, so it's going to go down. And the limit of x to negative radical 5 to the left is going to turn out to be positive and positive, so it's going to be another positive infinity. It's going to go up. For step 7, you want to find where the points cross the horizontal asymptote, and in order to do that, you're going to set the horizontal asymptote to the function and solve for x. So you're going to do 0 over 1 equals x plus 4 over x squared minus 5. And when you get that, you're going to get 0 is going to equal to x plus 4, and x equals negative 4. That's where it's going to cross. On the next page, we're going to graph the equation. you're going to graph the point at -4/5 and -4. Next, you're going to graph the horizontal asymptote, which is at -0, at 0, sorry. And for the vertical asymptotes, you're going to graph it at -radical 5 and positive radical 5. So it's going to be right in between. Okay. And since the positive radical 5 on the right side was up, you're going to place this in the up. And since this goes up as well on the left side of the limit, you're going to do that. And you're going to, since this on the right side of the negative radical 5 goes down, so you're going to put it as that. And then the right and the left side of the positive radical 5 goes down as well. And you're going to graph it from here. You're going to take this from here. So the cross is the horizontal asymptote at -4. That's where it's going to be. This you just bring down, get to the closest line as possible. And for this, you're going to connect these two. Make sure you connect the point. And that's it. I'm done. That's how you graph a rational equation. Okay, so in conclusion, there will be no removable discontinuities because there is no simplifying in the beginning equation, so there's nothing to cross out. So it cannot be a slant. It cannot be any removable discontinuities, and it is not a slant asymptote because the exponent in the greatest exponent in the numerator is not greater than the greatest exponent in the denominator. And that is